You can see other problems like that in 10.6 in the textbook. And 10.7 is on polynomial and rational inequalities. And the polynomial inequalities are easier to do, and therefore we are not going to start with them. We're going to start with rational inequalities because it has all the rules. Its rules apply to polynomials. Completely. But not true the other way around. Are you guys ready for the glory? Go big or go home. A rational equation has fractions. So rational inequalities have fractions. We'll start in factored form to make it easier. And it has an inequality symbol. I'm going to show you the graph of this real quick. Just so you can get like an idea of why the fuck we're doing what we're doing. Maybe I should have done this in 335, but I didn't. I'm winging it because that's what I do. I'm a rebel. And you'll find out how to graph this at the end of the semester. So that's my equation without the inequality. It looks something like this. And the bottom is where we can't equal 0. So there's asymptotes there. Why is one darker than the other? So I'll do that. The lines don't cross it. The orange is our graph. Some areas it's above 0. Some areas it's below 0. Notice that the asymptotes, these vertical dotted lines, those are lines we can't cross, and shit changes at them. If we were below the axis before, we're above it afterwards, and vice versa. If we're above it before, we're below it afterwards. That isn't always true, but in this problem it is. The important part is shit can change at the asymptotes. That's the takeaway from this graph, okay? Shit changes at the asymptotes. So, from the Desmos bit, shit can change, positive or negative, at the asymptotes. And that's how you spell asymptotes. And these occur when bottom equals 0. All right, well, let's look at the graph again, see where else we saw where it changes. This black line right here is the x, y equals 0 line. So it looks like it's changing at -5. It's positive to the left of it and negative to the right of it. It's changing at -5. And at +6, it's negative before it. It's negative before it and positive after it. Well, 6 and -5 just so happen to be where the top is 0. So where the bottom is 0 can change shit, and where the top is 0 can change shit. That's the full takeaway. Top can change signs where it equals 0. So all of these affect it. And rather than doing the full graph, like we're not ready to do, if you just want to know where it's positive or negative, we can use a sign chart. Okay. So we can see the top can equal 0. If we set it equal to 0, we see it can happen at x equals 6 or x equals -5. Based on the initial inequality, can I include 6 or -5?
No,
Why?
the points, right?
Well, if they're points, is there a problem if I plug them in? That's the real question. Is there a problem if I plug them in? If I plug in 6, the top left one is 0. That one's 11. That one's 7, and that one's 4. And this is 0 times 11 is 0/28, which is 0. Is that greater than or equal to 0? It's got the equal portion, so yes, it's valid. Same with x equals -5.
It doesn't change anything, but it's supposed to be a 3 instead of a 4. On the bottom.
Right. I did this, I plugged in 7, not 6, but I'd rather have it right, which makes that a 21. But anyway, you're right, it doesn't change that. So that means I can use x equals -5 and I can x equals 6. I include the points, the x equals -5 and -6 or +6. For the bottom equal to 0. I have x plus 1, x minus 3 equals 0. And I get x equals -1 or x equals 3. And can I include these? No, gives me a 0 on bottom. So the sign chart uses a number line. And we want to find the intervals where, and I'll rewrite the equation, x minus 6, x plus 5, all over x plus 1, x minus 3 is greater than or equal to 0. That's our goal. And we calculated values on top, special values of 6 and -5. And on bottom, we got -1 and 3. Collectively, these are called the critical points. You might see the word critical numbers or values. When we looked at Desmos, we call them critical is because that's where shit was changing. Shit can change here. I say can, it doesn't always change. We'll see. There's scenarios where this doesn't change. So what we do is we make a number line with those things, those values on there. And -5 is the lowest one. And then I got -1. And then I got 3. And I got 6. Okay, I'm gonna put circles on each of these points because these are all of our critical points. I'll put CP above them, that way we don't forget. If we're doing interval notation, we use solid points and hollow points. When we were doing interval notation back in chapter R, remember? And it was the hollow points are if we can include a number, and solid points are if we, hollow points are if we can't include the number. Solid points are if we can include the number. We determined that we could include top, but not the bottom. So we can include 6 and -5. I'll put include over them. And we can't include -1 and 3. And we'll talk about the general rule after we do this problem. Okay, so we plot our critical points. And then we're gonna turn them into regions. Make them into boundary lines, boundaries for regions. Or zones. So -5 will be a boundary line. -1 will be a boundary line. 3 will be a boundary line. And 6 will be a boundary line. Now, the next part is important that you understand the premise of it. And I'm going to use Desmos, the graph of it, to prompt why. So I'm going to go back to Desmos real quick. I want to give you like another 30 seconds to finish writing this because we're still right. Anyone need longer? Everybody look, I don't see pins moving. Okay. So we had -5, we had -1, which is this purple dotted line. We had +3, which is this purple dotted line, and we had 6. Those are our regions. In fact, I will throw down lines for the other two. X equals 6. And I'll make these red. Oh. Or green. Let's go with green. And I'll make these both dotted. And I'll make these both slashed. So these are our lines that we have on our sign chart right now. These dashed and dotted lines. Everything before -5 is positive, no matter which value I pick. Everything between -5 and -1, the y value is negative, it's below. No matter which x I pick, the y is always negative. Between -1 and 3, no matter which x value I pick, anywhere on this x line, if I find the y corresponding y value, it's positive. The same thing happens between 3 and 6. They are all below the axis, so they're negative. And after 6, they are all positive. We saw the graph, so we know where this is going to turn out. But the important takeaway from that was, doesn't matter which number I use, they're all going to be the same. It's all going to be the same sign. So regardless of test points I pick, the overall sign will be the same within a region. So I'm going to pick test points that in the region that I like, that I think are useful. I'm going to pick 0 to be a test point, because plugging in 0 is always easy. I'll pick a number between them, -3. Over here, I'll go with something big like -10. Here I'll use 4. And I didn't draw it in the center of the graph, or I drew it in the center of the graph, but 4 is closer to the 3 than 6. That doesn't matter. These are just test points right now. And I'll do 10. All right, so what we're going to do at this point is do our equation, let me bring it back down, do our equation, but replace. X value with temp or test points. I'm gonna do that below. I got a lot of room here. So my test point here was 0. I'm gonna just plug these in. So if I clean this up, I've got -6 on top, 5 on bottom, 1 on bottom, and -3 on bottom. If I multiply this out, this is -30 over -3, which is 10. 10 is greater than 0, so I'm gonna mark this region as positive. I'll do another region the same way, and I'm going to illustrate why the current way that I'm doing it sucks. I'm plugging in my test point, which is -10. And I'm going to give myself a lot of room. That's -16 times -5 over -9 times -13. $16 times 5 is 80, and the negatives cancel. 9 times 13 is 90 plus 27 is 117. And the negatives cancel down there. So this region is positive as well. Does that seem pretty fucking tedious? Especially like multiplying this stuff out?
It makes more sense to me. Yes, it's tedious, but at the same time.
Okay, so you can do this method every time. To calculate and get the actual fucking value, decide whether it's positive or negative, you can multiply it out. But if you're like me and like time is finite, unless you're immortal, you have a limited time on Earth, and wasting as little of it, getting the problem right is beneficial without cheating. So does it matter if this is 80 over 117 or 1 billion, as long as it's positive? No, it doesn't matter, right? So these numbers don't matter. The only thing that matters is the signs. So that's a negative on top. On bottom, they're both negatives. Putting them together is not too bad. That's not too bad. You can find the negative that way. Count the negative signs when you do like an even number of negatives turns into a positive region. And an odd number of negatives is a negative region. Here I had 4 negatives. That's even, so it's positive. So I didn't have to actually calculate what the numbers were. It's a little simpler than that.
Well, would we have to, if we were actually drawing the graph that was on Desmos, we might have.
We've got better ways to do that. The test points you would know, yeah. If you really want to know where a specific test point is, you need those numbers. But in general, no. So I'm gonna set this up with the -3. I've got -3 minus 6. -3 plus 5. Over -3 plus 1. And -3 minus 3. So I get -9. 5 and -3 is 2. -3 plus 1 is -2. And -3 minus 3 is -6. That isn't the better way yet. I wanted to show something. And this, doing one of these ones was a little bit easier where the sign ends up being negative. Look at the bigger number in each of these parentheses. That's the bigger number, that's the bigger number, that's the bigger number, and these are both the same number, so it doesn't matter. And now look at their signs and look at the resulting signs. -6 was negative and I ended up with a negative. 5 was positive and I ended up with a positive. -3 was negative, so I ended up with a negative. And 3 was negative there, so I ended up with a negative. All you gotta really do, rather than even calculating the number, is look at them and go, which one's the bigger number? What's the sign of the bigger number? In each parentheses. So I've got a negative, a positive, a negative, a negative. I've got 3 negatives, so the overall region is negative. I'll do the same here. And I'm just going to track the sign of the bigger number in each region. I've got a negative, a positive, a positive, a positive. I've got 1 negative, so this region is negative. Again, if you don't like this, you can always multiply everything out and figure out what the number is. And decide if it's positive or negative. Here, if I plug in 10, 10 is bigger than all the numbers. So every single one of these parentheses is positive. Positive, 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 positive. No negatives, so it's a positive region.
Is it always going to go positive, negative, positive, negative, positive?
No.
No.
No. We'll do an example. I want to finish up this problem, then we'll do like a speed run on another example where it changes.
Is there, I was gonna say, there's another equation for when that waffling effect continues to happen again, right? Where there's like an infinite number of regions.
Yeah, they're like sinusoidal waves out and stuff like that.
Yeah, that's it.
That's another class.
That's not-
Okay, so we're not done. We have our regions. I'm gonna bring them down right here. I'm gonna like do a real quick. We had -5 and it's filled in. I had -1 and it's hollow. I had 3 and it's hollow. And I had 6 and it's a solid point. And I have positive, negative, positive, negative, positive. And our equation was x minus 6, x plus 5 over x plus 1, x minus 3. Greater than or equal to 0. Okay. We want values that are greater than 0. Greater than 0 means positive regions are what we want. So the intervals where this is positive, we start at negative infinity. We go up to -5 and we can include -5. We start again in -1 and end at 3, but we don't include either one of those. And we start at 6 and go to infinity, and we can include the 6. And we put union signs between them. All right, so lower than -5, greater than 6, and between -1 and 3. If we look at Desmos, we can see that's where it was true. Less than -5 is above the x-axis, between -1 and 3 is above the x-axis, and greater than 6 is above the x-axis. So the graph confirms it. The general rules are never include the bottom values. Always hollow points. For the top matches inequality symbol. When we did regular inequalities, when we weren't doing any of these rational ones, we saw greater than or equal to, less than or equal to, led to including it, which was a solid point. If we didn't have the equality portion, just strictly greater or strictly less than, don't include. Hollow. Those are the rules for inequalities. This rule applies to rational and polynomial. Nope, just rational. Because polynomials don't have a denominator. Polynomials don't have a fraction, so we don't have a bottom that can equal 0, so that's not a problem. This one applies to both polynomial and rational. So if you don't have any fractions, just whatever the sign is, tells you whether or not you use solid points or hollow points. The sign chart and everything remains about the same. Okay? So polynomials. Everything's the same. Don't worry about the bottom. Because there isn't. So I'm gonna do a polynomial and we're gonna speed run this with 5 minutes left. I'll give it to you in factored form. Let's do x minus 5 squared and x plus 3 cubed. And we'll say less than 0. So all points will they be hollow or solid? No,
No.
hollow, because there's no equal sign. You can still find the numbers by setting that equal to 0 and solving. So our critical points are x equals 5, x equals -3. I sped through that because if you take the square root of the cube root of 0, it's still 0. So all that matters is what's on the inside.
Is that always going to be true? All that matters is what's on the inside.
If you got it in factor form, yeah. And we already said these are hollow points. So I'll try -10, 0, and 10. I've got -10 minus 5 squared. And then I've got -10 plus 3 cubed. So the square tells me there's 2 parentheses. The bigger number for all of these is negative. So this one gives me a negative times a negative because of the square. This one gives me a negative times a negative times a negative because of the cube. I have 5 negatives. This region is negative. This one's pretty easy. Plugging in 0 just gives me the number. -5 squared times 3 cubed. This is 25 times 27. They're both positive. This is a positive region. If I count the negatives, there's 2 from the square and the rest are positive. 2 negatives, this is a positive region. And if I stick in the 10, that's a positive and a positive. That's a positive, positive, positive. There are 0 negatives, so this region is a positive. So notice it didn't change signs. We only wanted negative regions. So the only region that applies is this. And my answer would be -∞ to -3. Something special made it so that the sign didn't change. Why didn't the sign change here? As we crossed 5, what was special about the point x equals 5?
Squared.
It came from the square. Oops. So parentheses with an even number up here won't have sign changes across them. If the parentheses is odd, it has a sign change. And that's true on the polynomials and the rational equations. Even the rationals, if I have 1 over x squared, x equals 0 is a problem, but it's going to be both positive. So we only got like 2 examples in, but we got hit all the rules, and I think going slowly and doing the graph and like comparing them as we went, I think is better than doing like 5 problems and not seeing that comparison and getting a better feel. It's 5 o'clock. Well, it's a little after 5. Godspeed. Get the fuck out. Have a good day. Bless you all. Oh, there is an announcement up. I put it up yesterday. If you could check it out tonight, if you haven't already done it, it's a feedback on the Alex. I am talking to one of the reps tomorrow, and I want to like, if there's anything I can change to make the rest of the semester easier, the best people to ask is you. So give your feedback. I'm going to take the feedback to the lady in the bar and go, what can I do to make this shit so that the class is more tolerable? Because some people don't like Alex a lot, and some people are happy with it. So if you like it or don't like it, there's lots of questions, 4 or 5 questions. Give me a review, please. It's anonymous, so have a good day.